Yeah, so the fuel switching recommendations that people have explored have mainly been based around four different types. So the first one being biomass. So this is everyone's pretty familiar that this has been pushed as a big one, and it is a good choice, although there are some disadvantages to it as well. So you can just convert your coal boiler, which is a nice benefit of using biomass. This takes some of the capital cost out of it. You do end up losing a bit of efficiency because when you convert to biomass and you are repurposing an old asset, so depending on what age your boiler is, could make it more or less worth it for you to actually convert your boiler. Wood chip, so wood chip is a cheaper fuel source than wood pellet. You do require quite large volumes of storage for wood chip. I think it's three times compared to coal and wood chip. And then it's not as fuel dense as wood pellet, and there are more transport costs because there's quite a lot of void space for those wood chips, so you're getting quite a few more trucks coming through depending on the size of your plant. Wood pellet is the most expensive wood fuel type just because it has to be processed into those pellets, but there are significant advantages to it. There's less storage requirements for wood pellet. They're much easier to handle because of you're able to just blow it into the boiler rather than your auger that you need for wood chip. And then less transport costs just because it's more fuel dense. So Marcus here, they sell the Okofen boilers. So these are the containerized wood pellet boilers. These come in one large container. They use wood pellet for fuel, and they're a quite good sort of plug and play unit. And if you're interested, you can talk to Marcus more about it, who's standing over here. And then Polytechnica, another one who've worked in the horticulture industry before. I'm trying to see if he still, so they've done quite a few of their wood chip boilers around in the horticulture industry and around in Australia and New Zealand. That's right?
Yeah, we've done 10 large installations in Australia and New Zealand. If I just can add something, none of our customers burn wood chips or pellets. They burn forest residues and hog fuel and sawdust and whatever is a residue, because they are often substantially cheaper than the high quality fuels.
Yeah, that's a good point. Time Bank down south, they are an operation that use pine nut shells to burn, so that you're right, there are different options besides the wood chip and wood pellet that can be considerably cheaper if you build that relationship with someone who has a significant amount of waste biomass fuel to use that as an option. So it's definitely worth exploring. Electric boilers. So electric boilers have popped up in some of these consultant reports. They haven't been recommended as much as, say, the biomass or the heat pumps that I'm going to talk about later, mainly because they have quite a high operational cost, because electric boilers they put out as much electricity that you have to put into it. So when you compare it to a heat pump, you'll put in 1 kilowatt of electricity into it, you'll get 3 kilowatts of heat out of it. And I'll explain more about how that works later. They do have a lower capital cost than heat pumps because a lot of them are just pre-bought units, so you can just stick them in and they'll run. They are very easy to use, very simple, very quick responding. You can go from 0 to 100% to 50% to 10% in very, very, very short amount of time. And then low maintenance. So those are some advantages, but the high operating cost and the infrastructure upgrades that you could potentially need, like transformers, line upgrades, things like that, make them a bit more difficult as well. Air source heat pumps. So air source heat pumps are always one that are looking very, very promising. So air source heat pumps you can either use to generate hot water so that you don't need to replace your full system, or you can use them as air blowers where they'll be just blowing hot air straight into the system. So again, a high capital cost. Prices range from 16 grand for a 15 kilowatt unit to decking out a 330 kilowatt site for $500,000. You get low operating costs due to the high coefficient of performance. So the electricity you're putting into a heat pump is going into compressing. The heat you're getting is mainly coming from the air as a fuel source. So you instead put that out, and so again you'll use you'll put in 20 kilowatts of heat, of electricity, you'll get out 60 kilowatts of heat. So they're actually operationally quite good for your electricity bill. You can have lower infrastructure costs, but again, depending where you are and how good your electricity supply is, it can still be quite difficult and expensive to install the new transformers and get the line upgrades. They can be used for cooling as well as heating, so this is a huge advantage for some sites depending on where you are, because I know that some of the sites have had serious problems with their produce overheating, so this is a good benefit. Vulnerable to power outages, that is an issue, especially for some people we've seen down in the South Island, where in the more isolated areas they have power outages, and because of that they need diesel generators. Obviously that's not preferred, but that is a weakness. Vulnerable to cold snaps, again this is maybe more for the South Island, but these air source heat pumps will work up to about -5 degrees Celsius. If they go lower than that, then you'll lose quite a lot of that efficiency, but -5, if you get down to -5, you'll still be getting a coefficient of performance of about 2.2. So you'll still be putting in 5 kilowatts of heat and getting out like 12. So it's still not too bad. Next, please. So yeah, you got the 100 kilowatt hot water heat pump, and then your air-to-air heat pumps, pretty standard. Next, please. Ground source heat pumps. So ground source heat pumps use the reasonably consistent temperature in the ground as your heat source. So normally, depending on how deep you go, you can get consistent temperatures of 14 to 20 degrees, even higher depending on where you're located. The other thing that some people have done is they've used maybe a body of water for a heat source. So by using that body of water as a heat source, you can get a much more consistent performance. Very, very low operating costs because you are using such a high temperature source for your heat pump. You get very high COPs. So if you're putting in 20 kilowatts of heat, you can get up to 100 kilowatts to 140 kilowatts out into your site. Again, can be used for cooling like the air source heat pumps can as well. Has many of the same advantages. The design can get quite expensive because they do have to, in some places, drill quite far down. Works in all climates and is consistent when compared to air source heat pumps. And then there can be less electrical infrastructure upgrades as well.